For me to introduce our speaker for this evening. Dr. Pippa Horton has kindly offered to answer your questions after her talk. Please will you write them in the chat and then we will pass them on to her. And by the way, you can save the chat. So if you want to take all the questions and answers away with you, then you can do that. Dr. Horton is a business manager to UK Fires, which is a research programme working with industry towards a rapid transition to zero emissions. She coordinates the industrial consortium and leads outward-facing activities with industry, NGOs and government. She worked for 3 years for Jaguar Land Rover, so she doesn't just talk about it, she does it. Before completing a PhD at Cambridge University, exploring opportunities to reduce the 50% of their sheet metal purchasing, which is currently scrapped, and make potential multi-million pound savings. Within UK Fires, Dr. Horton has brought in several new subscribing partners to the industrial consortium and is supporting commercialization activities which bridge the gap between academic studies and industry, which is of course really, really important. So I'm very much looking forward to what she has to say. Over to you, Dr. Pippa Horton.
Thank you very much, Jane. I will share my screen. Is that, can you see that okay?
Perfect.
Excellent. Thank you for that introduction. So UK Fires is probably not a name that you're familiar with. University of Cambridge probably is. And what UK Fires is all about, along with all the other researchers looking at zero emissions, is rather than thinking, what do we need in 2050 to have no emissions? We think about what will we have in 2050 and how can we use that to live a life that's prosperous with no emissions. And flipping on its head that way makes the plan more realistic, less risky, and hopefully I'm more confident that we can reach zero emissions by 2050. So this graph shows the emissions over time. And can you see my pointer when I put my pointer on the screen? I don't know if that's visible to you. Yeah. So this is over time, and this is our emissions. And you can see all of these events are when we're speaking about emissions. So on a global stage, we're speaking a lot about reducing emissions, but our emissions keep going up. We actually haven't reduced them at all. And that's because there are two stages of technology development when we're looking at reducing emissions. The first is find a new technology, invent something new, have a magic bullet, and we have to gain experience when we do that. And the second is deploy that technology and scale it up. And at the moment, most of the focus, or all of the focus, especially in COP26, is all about things that are still in the gain experience category. So we're still learning how to do them, and we're not actually doing them. And what we need to do more of is the deploy, the second stage. And actually, we think that's quite dangerous because the more that we talk about NET as negative emission technology, that's what that stands for on the side. And the more we talk about carbon capture and storage, hydrogen, negative emission technology, the less we do the obvious stuff that we actually really need to do. And an example of that is because we're hoping that the problem's going to be saved by new technology, we're still having hotter houses, we're eating more meat and we're flying more. So we're not taking the actions that we need to do to reduce our emissions. And this is explained, this graph here is from the Climate Change Committee, who published the budget to say, how is the UK going to get to zero emissions? And the black line at the top shows what the emissions would be for the UK if we didn't do anything, if we just stayed the same. And all the colours are blocks that say, this is how we're going to do something to reduce those emissions, and then it goes down to zero. And I've simplified this into these categories. So to reduce our emissions, this Climate Change Committee thinks we can substitute different materials. So instead of using steel, we might use timber to build buildings. We could be more efficient, so we could have energy saving devices. We can change our electricity to renewable energy that doesn't have emissions. And then there's these two big blocks at the bottom, negative emissions and biomass. But the problem that we find is that negative emissions and biomass sit in that stage one still, we don't actually have any negative emissions yet, and biomass can't be scaled up much more than it is already. So what we think we actually have is just this non-emitting electricity part. And we don't think that the negative emissions are going to be available by 2050, because it takes a long time to deploy new technologies. And we haven't got a long time to 2050. So that means we need to make a bigger effort with the efficiency. So our projection is to say, rather than just having a small amount of efficiency, we need to put much more effort into having energy efficiency. And then substitution is in our plan as well. But then we have a gap. So we think that in order to get to the zero emissions by 2050, we haven't got solutions for some of our activities. And that's what, at the moment, we're feeling in restraint. So at the moment, we don't know how you can eat beef without having emissions. So the only way to not generate emissions from eating beef is to not eat beef. And that's a really difficult thing to process, especially as a politician. But it's really important to be quite clear about these things. If it makes emissions, you have to accept that those practices make emissions. So that bar chart's kind of a bit fuzzy. So if we'll break that down a little bit more, how do we actually get to zero emissions with the technology that we know we're going to have in 2050? So the first thing is emissions come from either energy or processes. So the processes that create emissions, we need to remove them. And they're things like chemical processes or waste processes or land use. And then the rest of the energy, the emissions come from energy. So if we look at those energy, we've got a combination of fossil fuels and electricity. So step 2 is we have to electrify everything. We have to get rid of all of the gas and oil, because when we burn them, that releases emission, and we can only have electricity. And we can only have zero emission electricity as well. Step 3, I've just magnified that electricity, and you can see actually coal and gas make a big part of that electricity mix. So the only electricity that we're going to have available is the renewable, and there's a lot less. So step 3 is use much less electricity. And that's a very simplification, but the idea is of how we go from where we are now to how we get to zero emissions. And using less electricity is something that isn't discussed very often. And that's because there's an assumption that we're going to grow the renewable electricity that we have available. And that comes from that idea that I said at the start of UK Fast, flipping it on its head. So rather than thinking of how much energy do we need, we're thinking of how much energy do we have. And I'll show you the difference between those 2 points. This graph's a little bit complicated to understand, but the most important thing is all these bars that come up. That shows how much new energy is added to the grid each year. And it's about 3 to 5 gigawatts of energy. And the blue box at the top is if we were to meet the CCC's projection of getting to zero emissions, those kind of pink lines that you see would have to sit between 9 and 12 gigawatts per year. So every single year, we would have to have about 4 times the amount of energy than we've ever put on the grid before. So that block would have to be full. And I'd quite like to be optimistic, but even that just feels like a really, really big stretch. And there's no way that we could scale up energy production to fill that graph. And that works out as about 315 gigawatts. So what UK Fires has done instead is to said, how much energy are we producing at the moment and how fast are we deploying it? And then we've taken a linear rate forward. So you can look at this graph I've just done. Based on what we've had at 2020, we've said we're going to expand linearly and continue to add more energy at that rate, which is quite ambitious. And that gives us 62 gigawatts of energy. And you can see there's a really big difference between how much energy we think we're going to have and how much energy they're saying we're going to need. So we've translated that 62 gigawatts of energy and say, what does that mean for all the different sectors? And then this is what this bar chart on the right shows. So each of those colour blocks are how much energy we think we might need and how we might use. And this is based on our projection of kind of electrifying vehicles and using energy more efficiently. But you can see there's that big gap of about 40%. So we're only going to have 60% of the energy that we think we're going to need. So we're going to have to be much more efficient in how we use it. So we published all of this in a report called Absolute Zero. And the feedback we got from the catapult centres, which are set up to help translate research from universities and into industry. And they said, oh, we think that's really useful. It's good to have a different perspective, but we don't really know what we do with it. What do we do with industry? So you're telling us that we're being too risky and we're relying on technology that doesn't exist, but what can we do instead? So we summarised some assumptions to say, in the absolute zero world, you can only have electricity as your energy source. You have to stop doing anything that has emissions that you can't get rid of. You have to reduce your energy run by 40%, and then you can't have CCS, and you can only have a small amount of hydrogen, and I'll go into that a bit later, and that's because the hydrogen takes a lot of energy to produce. So we set these boundaries, and we ran a series of workshops with industry to say, if you had to follow all of these rules, what would your business look like? How would you run a business? How would you be prosperous? And I'm going to take you through some of those findings and some of those ideas that we had. So what does it mean for the big sectors? I'm going to try and answer those 4 questions. And this graph or bar chart is one that I'll repeat throughout to say, that's all the energy that we think we're going to need. And we only can go up to that green line at the top. So our kind of 60%. So let's start with buildings. The picture on the right-hand side is the current plan for regulations for energy efficient buildings, which is have quite leaky buildings and then put lots and lots of renewable energy into heating or cooling those buildings, and then using some kind of energy storage to cope with the fact that we have more energy available in the summer than in the winter from, say, our solar panels. And actually, a quick back of the envelope calculation, we worked out that you need about a battery the size of a shipping container in order to store enough energy for one home between the summer to get you through the winter. And that's just not feasible. You can't scale up that kind of energy generation and energy storage. So the better solution is on the left-hand side, which is the example of the passive house, which I'm sure most of you will have heard of before. And if you haven't, have a look. They've got a really fantastic website. And the idea is that you insulate your building better. You use your energy much more efficiently. So you need much less energy and much less energy storage. So what businesses would do well? Who's going to do well in a world where you can only have the technologies that you have today, but you still have to have zero emissions? And that's anybody that electrifies heat. So heat pumps, we're going to need loads of engineers to install heat pumps. We're going to need to train those engineers in how to work, and the colleges and all the surrounding infrastructure support electrification of heating. The same with cooking. We're going to have electric cookers and new buildings that are designed to be energy efficient. And we know that needs to happen. So the building designers that do that first will be an advantage. But actually, in 2050, most of the buildings that will be around are already built. So the biggest opportunity in zero emissions for buildings is all about retrofitting those buildings, insulation, loft insulation. And if I had any spare capacity to run a company, I'd be looking at investing in a company that did heat pumps and insulation, because we're just going to need so many of them. The final one is less obvious, and that's the idea that if we haven't got as much energy available, there is a genuine risk of energy shortages, power shortages, and that's something that some companies will have devices. So your washing machine now can be quite smart and can turn up in off-peak times, or you could charge your car in off-peak times to manage that flow. But there will also be backup generation required or energy storage required for the points that if we might have an energy shortage or intermittent energy availability. So hopefully you can see I've now brought down the blue block. So the idea is that while we worry about the energy and we say our homes need a lot of energy, actually there's a lot of opportunities out there for us to reduce our demand for energy. So it is feasible in buildings for us to live well with about half as much energy as we currently use. So if we have a look at transport next. There are quite a few charts in this graph. I apologise if you don't like a bar chart. So the chart on the left-hand side shows how much energy we would need to run our transport system based on the government's plans for the kind of zero carbon transport plan. So that's using synthetic jet fuel, using hydrogen for HGVs, and having electric vehicles. So in theory, it's zero emissions. But you can see when you compare to the smaller box on the right-hand side of the bar chart, that it uses much more energy than we will have available. So there are some things that we can do to address that. We can reduce how much we fly. We can use electricity instead of hydrogen, because hydrogen is very inefficient use of energy. We can switch from road to rail, share the journey, and we could be more active. So this is quite difficult for the existing, say, logistics providers or existing companies who use a lot of transport to think about, how can we integrate this in our business? How can we make this an opportunity rather than just something that we're going to struggle with as we get to zero emissions? So we had our workshop with them, and we explored these ideas to say, you can only have half as much energy as you really want, and you've got to run your process with zero emissions. And we thought the businesses that would do well are the businesses that actually use less transport. So when we go to the supermarket, what we actually want is our food. We don't want to travel in the car. That's just a way of getting there. And the same with work now. We wouldn't have thought before the lockdowns that we could be so effective at home working and reduce the amount of air miles and travel miles that we have to do for our work. And this is possible. So the companies that find way to have better logistics, more efficient logistics, will do well because they won't have to do as much transport. The next opportunity we call the payload fraction, which is taken from the language of aircraft and rocket design. And that's the bang for your buck. So how much energy do you have to put into moving something? And you can see with the two minis there, that actually you're putting a lot of energy into moving it, but the modern mini, which is meant to be lightweight and new technology, is much, much bigger than the original mini. So we'll need more energy to move the same people in the car. So there's opportunities in car design or in other transport design, not just to lightweight, but to make it smaller. We don't all have to drive in big vehicles all of the time. And then the train represents that actually, if we can use the most efficient mode of transport with more people, use more public transport, then you're getting much more transportation as a service for just one journey and one amount of energy. The next opportunity is in filling the empty space. So we've all been on a train in rush hour and you're packed in sardines, and then an hour later there's only 3 people on the same train and they still operate, moving lots of air up and down the country. But actually, instead of moving air, they could move our Amazon parcels or our supermarket goods. They could be loaded on and off, and that would create huge opportunities, not just for the rail sector and the train, but also for all the infrastructure and the stations that would now need logistics services provided and activity hubs to enable those services. And then the final one for transport is about electrification. So we know we have to electrify, and that's been quite accepted by the transport sector, but we don't have to electrify by 2050 if we could go faster. So why wait until 2050 to put all the electrification systems in? If we know it's going to happen anyway, we can do it faster. And that would be a really big help because transport is easier to electrify than some of the other sectors. So see now the orange part of the bar chart for transport is reduced. So although that first graph was quite daunting of how much energy we think we're going to need and how much energy we've got, there are actually lots of opportunities to reduce that demand for energy. And there'll be lots of ways for businesses to make money and be prosperous in a zero emissions transport industry. So next I'm looking at materials, and I'm going to focus on steel and cement, if that's okay, because they're the ones that I know the most about. So how can we build without emissions, specifically with steel and cement? So the way that you make steel at the moment is you use either what's called a blast furnace, and then that's how you make primary steel, new steel, but that creates emissions. So in order to do that without emissions, you'd have to have CCS. The alternative way is what they call an electric arc furnace, and that's using recycling and doesn't generate emissions. But in our absolute zero scenario, we've said you can't have CCS. So you can't have a blast furnace. So we've only got recycling left. You can't have the new steel. You might have heard about hydrogen steel. So you can do what they call direct reduction or a basic oxygen furnace and add hydrogen. But the most common form of hydrogen is generated from natural gas. And that's converted into hydrogen through a process called steam reforming. And steam reforming produces carbon dioxide emissions. So actually, we can't make steel using grey hydrogen. You have to make it using what they call blue hydrogen, which does the same process but captures CCS. I've told you at the start that we can't have CCS because we don't think we'll have deployed CCS by 2050. So you can't have CCS, you can't have blue hydrogen, so you can't have your direct reduced steel either. One final option is to look at green hydrogen. So green hydrogen is when you use electrolysis from water and it doesn't have emissions. And there is one plant that's currently being planned to produce green hydrogen and steel using green hydrogen by 2040. So that looks good, we can do that. But now I'll explain the comments I've made about why you don't want to use hydrogen. If you imagine this bar represents how much steel we currently make. Without any energy restrictions, we can make as much steel as can fit in that green bar. But I've just told you that by 2050, we're not going to have as much energy as we have now. And actually, we have to reduce our energy demand by 40%. So if steel takes its fair share of that hit, we can only make as much steel as shown in the secondary bar. If we made that steel using hydrogen, you can only have that much steel. And that's because hydrogen uses 40 times more electricity per ton of steel than the other methods. And an incredible statistic I read is that Germany have been looking at switching to hydrogen steel, and they found that they need to increase their national electricity production by 20% in order to support the steel industry. So in a time when we're trying to be energy efficient, they need to increase their whole grid by 20% just to fix the steel problem, let alone all of the other uses of electricity that they're going to have. So if I go back to my options, we cross hydrogen off the list. You could do it if you really wanted to, but it's a real waste of what is going to be a scarce resource of energy in 2050. So the option is recycling, and I'll come on to that a bit further, but we can make steel by recycling. We do know how to do that. And the next material I want to talk through is cement. So cement's quite a simple product, and it's quite a cheap product, but the challenge is there's a chemical reaction that happens in the production of cement, which is shown in this diagram, and that produces CO2 emissions. So at the moment, you can't make cement without having emissions. There are plans, again, to have CCS with cement, but at the moment, there's been no investment decision on these plans, and there's no existing plants in the world, and they're very expensive to do. So if you imagine building a plant like this, might take 10 or 15 years to do, and we haven't got any yet. To think that the whole of the cement industry will be implemented CCS by 2050 just doesn't look likely to happen. We've at the university developed a technology for recycling cement, taking old cement and then recycling it back into new cement. And it's really exciting, but it's very, very early stage. And because you can only use the recycled material, it couldn't necessarily meet the whole demand that we've had for future cement at the moment. So the big lesson for cement is, at the moment, we don't have any. If we need cement with zero emissions, we can't make it yet. So what does that mean for building? And it's quite difficult to have a workshop with the construction industry and say, how could you do your business? But by the way, you can't have any cement because it generates too many emissions. But actually, we did find some opportunities. So the first big one is refurbish. If you can't have cement, then you just want to avoid building as much as possible. So any building that you can, retrofit, refurbish it, repurpose it, convert it into something new, but just do not demolish it unless it's unsafe. Don't demolish it. The second one is plan for less material. So part of the planning cycle should be about avoiding demolishing, but also this building here has been extended vertically, and that's much more efficient use of materials than demolishing and building a whole new building. Another option is design efficiently. So this is a screen grab of some software that we've developed to help design buildings. And when you design the structure of a building, so that's how far apart your columns need to be, or whether they're made of steel or timber or concrete. When we design the buildings, our study showed that the embodied carbon in buildings is double what it could have been if it was designed with the most efficient solution. So we understand there's a trade-off with cost, but actually the most efficient solution was also 20% cheaper than the existing solution. So there's a real opportunity there to design for reduced carbon. The next opportunity is material constrained design. So that's the idea of, if we haven't got cement, don't design to use cement because you haven't got it. Design buildings to use more timber, or design buildings with the material that's around you. So that might be reusing from another building next door and repurposing it and designing that into your new building. So it's a new way of thinking, but rather than thinking about the construction industry as building things, if we think about them as providing the services that buildings have, so providing office space or workspace or living spaces, then actually construction doesn't have to be all about building new things. It's just about how you provide those spaces, which could be through refurbishing. So you can see I'm slowly inching down and we're nearly there. Materials is reduced, and there's lots of opportunities that we can build and have a construction section with much, much less steel and cement. So the final option is for manufacturing. And I'm going to look at both the UK manufacturing and that pink section at the top of imported goods, because although they're made elsewhere, we're still responsible for the emissions in the goods that we import. So what businesses could do well, and we pose the same question to these businesses to say, you can't have CCS, you can only have a very small amount of hydrogen because you don't have much energy, and you have to use only 60% of the energy that you use today. And there were some exciting opportunities. So electrification of the production. At the moment, glass is manufactured using gases, and that uses emissions. But actually you can electrify the glass production, and there are some companies who are already doing that now. High quality recycling. So I said we could recycle steel, and it's true, we can recycle steel, but most of the steel we recycle is recycled to a poorer quality, and that's because it has copper in it. So the copper that we have from our electrical wiring is mixed in the melt with the steel. And then when you try and draw or shape the steel, it's not very ductile anymore, so it doesn't work. So our recycled steel can only be used for things like reinforcement bar in concrete reinforcement. So there's huge opportunities to have better separation, take the copper out before we mix it all in, or have closer connections between the end of life products and the car manufacturers and the steel recyclers, to make sure that the quality of the steel is much better and it doesn't get downcycled. You mentioned in your introduction, Jane, that I did my PhD on the wasting the 50% of car manufacturing, and that's a huge opportunity. That a lot of these materials that we use, it's cheaper to use more material than it is to spend the time designing the process to use as little material as possible. But the economics of that will change as material and emissions become a much more important process in design decision making. We can also think of manufacturing a bit like you can do construction without building. You can do manufacturing without making things. You can keep repairing things. And we did a study on how can you have a zero emission car, and the answer was just never ever let it die. Just keep maintaining it, keep replacing products, because it's really hard to build something new without emissions. It's much, much easier to maintain it. And there are directors looking at longer lasting products and the bill for the right to repair, but this is an increasing area of growth for manufacturing that we can see. And then the final one addresses that pink box of imported goods. So at the moment we export 70% of our scrap steel. But if we want to have steel that's got no emissions, we need to generate the facilities and the capabilities within the UK to recycle it so that we can guarantee that it is that zero emission steel. And if we want to set our targets before the rest of the world, then we won't be able to buy it from anywhere else. We'll have to do it ourselves. And that's the same with lots of different technologies that will enable the transition to zero emissions. So the graph now you can see fits into our energy budget. So this is just a picture, it's not an actual measurement of what's possible. What I hope I've inspired you is to say, actually, while we're thinking of carbon capture and storage or hydrogen as technologies that are going to come and save us, we're not actually going to reduce emissions, and we're going to carry on that trajectory that I showed at the start, that's just emissions will keep on increasing. But there are opportunities that we can reduce emissions, and businesses can do really well from it. We can have economic prosperity, but we've just got to stop thinking that technology is going to come and save the day, and start using the technology that we already have around us to do it. So my last slide is on how you can help. So this is a pie chart of where our emissions come from. What do we have to stop doing to do global warming? And it's fitting quite nicely that my first one is swap to electric car. If that's your talk on the 8th of December, that fits quite nicely. An electric car, swapping the boiler with an electric heat pump. And maybe that's something that you're not going to do immediately, but having the plans in place so that when your boiler does fail, that you already know how that transition might work, rather than having no boiler and having to make an immediate decision that you've got to replace the boiler with a light because you're cold and you need your heating now. Reduce your flying, stop using aeroplanes wherever you can, and reducing beef, lamb and dairy are ways that you can reduce your direct emissions. Some of the ones that relate more to the things I've talked through today, the bigger picture stuff, are things that you can influence at work. So if you have influence over decisions on how buildings work or new buildings rather than adapting existing one, that does make a really big difference. And buying materials from that are manufactured sustainably through electric production rather than processes that have CO2 production make a difference too. And then as a citizen or as a voter, there are things that we really look to ask the government to do. So expanding our knowledge to electricity supply. So the projection that I've made is much more restraint than the projections that the CCC make on how much energy we're going to need. But they're still ambitious. We still need to go as fast as we possibly can in generating non-emitting electricity and building the infrastructure in order to use electricity rather than fossil fuels. So I've gone really fast through lots of research, but our reports are out in full on the website. So Absolute Zero was our first report that looks at setting the scene and reducing the techno-optimism and having a realistic approach. -45 is our response to what government strategy should be. So the idea that the government has said by 2030 they will reduce emissions by 45%. So that's our outline of what the government is currently doing and what we think they need to do. Entrepreneurs, not emissions, is a log of all the different entrepreneurial opportunities that come out of thinking about emissions from the Absolute Zero perspective. And ZERPAs is a report which explains our option of having a financial incentive to say, if a company wants to use carbon capture and storage, they need to have it on their profit and loss accounts to say they're buying some of that in the future, so that we can make sure that not everybody is buying a really small amount of CCS and assuming that they're going to be the ones that get it. So I'll stop sharing my screen, and I haven't looked at the chat to see what your questions are, but I've seen it popping up, so hopefully there's some questions.
Thank you very much indeed. Wow, there's a lot to take in, but I thought you put it across in a really logical way, and thank you very much for ending up with the what can we do, which is what we always ask people to do. So yes, I can see there are lots and lots of questions popping up. So I'm going to get the chat up so I can see what people have been asking about, and I've got questions in my own mind as well. Anthropocene magazine, that was before that. Okay, William has questions, if not covered in the presentation, because he came up quite early with his questions. How can renewable energy be stored? How much is public support needed to make the changes? What happens if we don't get it? And 3, the world is not going to achieve net zero, so shouldn't we prioritize adapting to climate change over going for net zero? Okay, the adapting question is quite a different one. I think I'm going to put that to one side just for a moment, because otherwise we'll be here all night. William won't mind me saying that. What about the storage question? Yeah, storage is a real challenge, and actually we don't have a solution. Like I mentioned about, we all need a shipping container worth of battery to store the energy that we need. We don't currently have a solution for that. So reducing the amount of energy that we need
would really help us manage our storage requirements and reducing that. In terms of how it is, I'm not the right expert in energy storage, but there are lots and lots of researchers that are specifically focusing on that one. Public support is really important, and public support is actually one of the big reasons that we don't think it's possible to deploy the big energy infrastructure like carbon capture and storage by 2050. And that's on the idea that when you implement something like carbon capture and storage, you have to go through the process of political buy-in, of planning permission, of the local residencies accepting it. And if there's an accident, because this hasn't happened before, if there's a big accident, which probably would happen at some point, you've got to deal with the consequences and rebuild that public acceptance back in. And there is a risk that that won't happen in time and we won't have that public buy-in. And that is the same with lots of technologies, but that's the big risk. That's why it takes 22 years to build Hinkley Point Power Station, rather than kind of just the 7 years of actually construction effort that it takes. It takes much longer to do this big project. And that is a big risk. I just touch on question 3 on the prioritising, adapting. I hope that I've given you some optimism that the world can achieve zero emissions. So although it's difficult, and although I really advocate being realistic about the challenges, it is possible, and we have the solutions around us today. So focusing, we're not ready to give up yet. At least I'm not ready to give up yet.
It's probably a question of doing both, isn't it? A bit of adapting alongside all the things you're suggesting, just in case we don't quite get there.
Yeah.
And there are many parts of the world I've been reading about all sorts of things where people are adapting, and so I think there's a bit of both.
Yeah,
so
we're already feeling the consequences, definitely.
Yeah, there's a question from Alison. How close are planning regulations to only allowing energy efficient homes to be built? I don't know whether this is your specialist area, but do you know anything about that?
I'm not an expert. From a generalist perspective, understanding is not close enough. We need to do a lot more. So there was more policies in place that then got scrapped, and at the moment they're not stringent enough. But the big impact that planning regulations can have is the retrofit, because most of the homes that are going to exist in 2050 have already been built. It's only a really small proportion that are going to be the new builds. So the big impact we need to have is putting the planning in place and the support in place to support that retrofit. Thank you.
So we have a question from Edmund Gemmell, who says that 2050 is too late, and asks how we could accelerate all of these methods to keep us safe by getting to carbon zero 2030.
Yeah, so that was the argument I made with transport, was electrify faster. So we don't have to wait till 2050. If we don't have to, we shouldn't. We should go as fast as we possibly can. But actually, it does take time, mainly because of the investment decisions. Who's going to finance it? Who's going to pay for it? Where's it going to be? All of these solutions take time, and actually building the logistics and the support and the infrastructure projects take a long time. So I mentioned Hinkley Point take 22 years. If we want to build new steel production factories, if we want to build new train lines and energy distribution and electrical energy distribution and wind farms, all of these projects, 2030 is too close. We won't be able to do it by 2030. But if we can, we should. We shouldn't wait till 2050. I absolutely agree. We need to, anything that we can do, we need to do now. So
Leslie asks if you have heard of the recent Earthshot Prize winner.
Yeah, I have, and it made me really sad, because the hydrogen bubble has so much momentum, and everybody loves hydrogen, and it's just because the oil and gas companies put such a huge amount of money in a big press campaign to all make us think that hydrogen was going to save climate change, because they can use their existing infrastructure to feed us hydrogen instead of gas. And they did really, really well, and they were really successful. But you can see from the slide I presented on steel that hydrogen just takes so much energy to produce. And if everyone is going to use hydrogen, we won't have enough energy to do that. Maybe in 200 years' time, when we've built up the renewable energy capacity, we might be able to waste lots of energy and produce lots of hydrogen. But for now, hydrogen just should be selectively used for some chemical processes like fertilizer. You could switch to hydrogen in parts of the production process there, and chemical processes that you can't do with anything else, but you certainly shouldn't use it for power. It's just such a waste of electricity. And I was so sad to hear that they won that prize.
Oh, all right. So choosing between being efficient or doing without, yes, that was a very strong message that you came across, which is very good. I like to think that we are not stuck with current technology to find solutions. Think back 30 years ago and see what's happened since. Well, yes, I completely agree with that point, but I guess that what you're saying is that the particular technologies we're talking about at the moment just don't look likely to be safe enough,
Yeah.
sure enough, productive enough, big enough scale to be able for us to be able to rely on them.
Yeah, there's a difference between, say, like the iPhone that could grow exponentially, because actually the distribution of that, you can go very fast, you can accelerate that very fast. But energy infrastructure, historically, any switch from nuclear or to gas has always been linear. We've never managed to accelerate faster than a linear rate. And at the moment, the kind of the technologies that you have of say carbon capture and storage are less than 5%, so we don't have very much of them. So if we're going to accelerate those at a linear rate, we're still not going to have very much by 2050. And it's the difference of the different types. So I'm not against innovation, I'm not against new technology and doing things as fast as you can, but it's being realistic. If you're building a new bridge, you can't just skip the safety process, and you can't the planning permission, and all of those negotiations just take time. And in a democratic society, we just can't go any faster.
Rosie, do you want to make your next point yourself?
Oh, yeah, sure. Pippa, I was interested, you talked about adding electricity production to the grid. How much do you guys see? I didn't quite see where you saw us adding self-generation to like our solar panels on our roofs and things. Was that come into your building section?
Yeah, that's a really good point. So I haven't included it in today's presentation, but we have looked at kind of energy in general, and that delocalized energy generation is a really important part of increasing the energy that we've got to the grid, and actually gives some really good business opportunities. So rural farms that maybe are quite far away from the electricity network and can't plug into the grid might be near a rail line, and if we've got an electrified rail line, the rail companies could distribute that electricity and take that safe solar panel from a local farm. So definitely decentralized electricity generation is a really big part of getting as much renewable generation as we can.
So I have a question. You mentioned some things that we should write to our MP about, or put pressure on the government about, but you didn't mention subsidizing people insulating their homes. Surely that's a big thing, and actually stop putting them in prison for objecting about it. But anyway, that's a political point. But
feel free to write to your MP about insulating homes. You should definitely, that can definitely go on the list as well.
Yeah, we should be being encouraged to insulate our homes, and there should be lots of grants and things available, but really, as far as I can find out, there's hardly anything now.
Yeah, so I think heat pumps hopefully will be the next. So the legislation on electric cars really helped accelerate and help the industry set up, because they had that level of certainty that they were going to electrify, and they were able to make investment decisions towards that. And I think the decision on the heat pumps will be the next big one that will make that difference. And there's no point in installing a heat pump if your house is well insulated, because that picture of the two houses that I showed, if you're losing all the energy, the heat pump can't keep up. So once we've got the decision to say that we all need to switch to heat pumps, then that will force us all to have to insulate, and we will need the support and the infrastructure and the training and the skilled labour in order to do that.
If only everybody was working in the same direction at the same speed that your brain does. So, any more questions? There's some comments here, but I'm not sure whether they're actually questions. Green hydrogen, blah, blah, blah. So, Pippa, if people suddenly think of other things they wish they'd asked you. If I put them onto an email, sometimes this happens. People ask questions afterwards, say, oh, would Pippa know this? Would you mind if I sent you an email and said, oh, by the way, these 3 questions came up. Would you mind giving them a quick answer?
Of course, no problem. I'd be very happy to answer any follow-up questions. I think there's a lady with a hand up.
Alison's put her hand up.
Yeah, I can't turn my video back on, so I can't wave at you.
All right.
I just wondered, obviously you're talking about insulation of homes, and that's brilliant for what I might call traditional builds. I've got quite a number of friends who live in houses that have, that they have no loft to insulate. Everything's flat roof, and so they kind of fall foul of all of the kind of insulation, even if it was being kind of grants, etc. Is there anything that those sorts of properties can do apart from build another wall around the house or another wall inside the house and stick insulation inside that?
Yeah, you've got it. You can get roof insulation, as in on external
right
from the outside of the house. So if you can't do the inside of the house, then
yeah,
outside of the house,
go round. Yeah.
And I think that was one of the comments in the chat, that it's expensive to do and it is challenging, and actually we don't have the skills and expertise currently to be able to advise us on what those decisions we need to make. So even if we go and say, I want to insulate my home, I want to have an energy efficient home, I'm going to Google that to do, the answers aren't there, and it's obvious, and that's a skill set that we just think it has to grow. And if I was a betting person, I'd bet on I'd invest in an insulation company, because they're going to have lots of business, and it's something that we need.
Yes, they did do. They did do one sort of ceiling and insulated above, one bedroom. But obviously, you're dropping ceilings, etc. So if you can add to the roof and the outside, obviously you're not losing quite so much.
Exactly.
Thank you.
Great. Okay, nothing else has popped up on the chat, so I think we should all thank Pippa very much indeed.
There is one question.
Is that sorry? This one?
Catherine Jenner. By 2050, we may be busy firefighting the effects of climate change. Will there be enough resource investment to do what we need to do?
Yeah, so it's a really big task, and I don't underestimate the scale of the task, but actually investment in the last even 2 years has really changed. So now investment companies require businesses to publish their plan to get to zero emissions, and it's really hard. It's becoming much harder to get funding and investment if you don't have a credible plan. So hopefully the investment is going to be directed towards the technologies that are going to help us get towards zero emissions. And there's a lot of work that's been happening in the financial sector that they recognise that there's a need for an investment. But hopefully that investment will drive growth and economic growth, and we're not just spending money, we're developing a new economy that is self-sustaining. So it's a lot of money that's required, and we need to spend more, but that doesn't necessarily mean it's not possible.
Edmund Gemmell had his hand up.
Yeah. Hi, and sorry, I'm sitting in my car, so that's why you can't see me, and I've been in another meeting. And I did ask a question earlier on. Unfortunately, I rushed into my other meeting and didn't hear the answer. Pippa, it's quite clear that we don't have until 2050. I can see others have been commenting on it. Carbon budget runs out 2028. Tipping points go between 1.5 and 2 degrees. Can these things be massively accelerated if we gave the right targets?
No, simply was my answer to that one. Is where they can be accelerated, they should be accelerated. But 30 years in terms of infrastructure just isn't a long time at all. So when you build factories with furnaces, in the lifetime of those furnaces is going to be 25 years already. So we have to make the decision now, and that will still affect us in 25, 30 years time.
I just catch it, Pippa. So what I've heard tonight, I'm just wondering if this is something you'd like to comment on, that although we you're not saying no new technology. You're saying don't rely on it. It will help get us there faster. But what you are saying is much more innovation in thinking about how we think about the needs we have for heat and safety and things like that.
Yeah, exactly. So thinking of being innovative and doing more inventive and entrepreneurial things and new businesses, but not relying on big infrastructure technology. So don't wait for somebody else to come and take the problem away. And don't wait so that you don't have to change your behavior, you don't have to change your business model because someone's going to invent some negative emission technology and suck all the emissions out of the air. That's just not going to happen. And we have tools around us now that we could make a really big difference with. But because most politicians are saying we're going to carry on as normal and we're going to get to zero emissions without anyone noticing, we're not making those decisions because they're hard. But we can do it.
Yeah, I would comment that we've had a big, I work for a council, we've had a big consultation of all the stakeholders, all the departments, and everybody has agreed what the targets ought to be. And then everyone's been asked, okay, so how are we going to change X? How are we going to change Y? And what comes out is that although everybody agrees that we need a whatever percent, let's say 50%, the actions that they're prepared to take will actually give us 10%. And so, you know, exactly what you're saying, everybody is expecting somebody else to do it, to solve it. And, you know, it's a complete mindset change for everyone, every organization, every person. In my very limited experience, I've seen that writ large.
Mm-hmm. But it's making a difference. So we spoke to a structural engineering firm this week who've put it in their targets to change their project mix so they do less building and do more refurbishment. And you could never have imagined even 2 years ago that would be on a business plan, but they realize that if they want to be sustainable and they want to still be in business in 10 years time, they have to have a credible plan to get to zero emissions.
Can I just add in on the comment on the councils? I heard a presentation from Glasgow City Council in the last week where they've got a 2030 target for the whole city and they're really going for it. So if we can get more brave politicians and organizations to go for it like that, we might have a chance.
Brilliant.
Pippa, could I ask you, what level of confidence do we have in the recording of these emission quantities in respect of national and international recording of them? Are we getting consistent interpretation and predictions from around the world?
I don't think I can answer that, I'm afraid. That's outside of my expertise. So the big thing on reporting that I would say is about considering the importation and international flying. So the most emission targets are based on production emissions. So how much emissions, for example, does the UK produce, rather than how much emissions do we consume, which includes all of our imports. And that difference between production and consumption is really important in how you interpret the numbers. In terms of how accurate they are, that's definitely not my area of expertise, I'm afraid.
Thank you.
Okay, I think we have finished it there because we've reached 8:30 and we still haven't shown the film. Edmund, are you still there?